Good morning, everybody. So I'm Darshika Vikneshwaran. You can call me Vicky. I'll be your instructor for statics. So before moving into the class, some of the responsibilities from my side, I'll make sure I prepare for class. I'll treat every student fairly and respectfully and give you the highest possible attention in class and also even after class when you have questions related to the material. And I'll make sure that I present the materials in an equitable way and also I measure it, that means the assessment and assignments are in an equitable way. Your responsibilities as a student in my class will be like, be honest, communicate if you have any challenges or changes you have to be made, and give some effort to understand what is taught in the class. So pay your 100% attention and be respectful of others. So today's material, our learning objective will be first understanding the importance of statics in civil engineering or any engineering application. And we're going to recall Newton's laws of motion to apply to the civil engineering problems. So why is statics? You can wonder, like, why should I take this statics course? Is that important? So statics is everywhere. It quantifies the forces between forces. So what are these forces? These forces can maintain the balance, or it can cause an object in motion, or it can change the shape. For example, you have a ball. The ball is resting on a floor. So the ball is acting down and the floor is giving a reaction force. So the ball is in balance, that we call it as equilibrium. If I'm going to give an external force to the ball, so I'm just pushing the ball with my leg, so that ball is going to move in the direction which is pushed. So I can say that ball is in motion now. Now I'm thinking, okay, I'm pushing the ball and my friend is giving an opposite force, or some of you is coming and giving an opposite force to my ball because you don't want me to push the ball, so you just put it back. So the ball, if these two forces are balanced, then the ball is going to be in station. But if you increase the forces, but at one point, if the ball is a rubber ball, it's going to change its shape. So forces make it to be balanced, or it can cause a motion, or it can change the shape or anything. So statics is very essential for many branches of engineering, civil, mechanical, aeronautical, and bioengineering. So because statics is like the fundamental where you're going to see how these forces is going to change your motion or your object in any ways. Thus we call it equilibrium. So the examples, let's see some examples. First one is a bridge design. So what's this bridge is going to do for us? So you can see there are many components in the bridge. So we make sure the bridge satisfies its purpose for construction. For example, we are going to pass vehicles or people through the bridge. So first, our goal is to make sure that bridge is doing its work. So for example, the bridge has, you can see this pillars like foundations will build on the bridges. There'll be loads from the vehicles. So there are going to be vehicles in the bridge, and also there's going to be people walking here. So they're going to be weight, and each and every truss member here, they're going to be forces between them because they are in balance force. They're going to be stationary. So we make sure that all these forces are equilibrium. There is no any resultant force. Although the weight comes from vehicles, unexpected vehicles, we make sure these columns and our foundations give forces to bear all those forces. And the other one is wind turbine. We have wind turbines for producing electricity through wind energy. So the wind is going to come and the turbine is going to rotate. So this wind energy is going to create a huge momentum on your top. So we make sure, so this turbine's body is going to bear the total moment that is coming from those blades. And then we have a dam. You can see how a single wall is bearing all the water load coming from here during heavy rainfall or during flooding or anything that's going to hold those weight, right? So somewhere here, we are making sure that our dam is enough to hold all the forces from this water load. So these are some of the examples in our civil engineering, but there are a lot of varieties of examples. So what if that is not in equilibrium? So what if an engineer failed to do his or her job and say, to calculate or miscalculate something. For example, okay, you have a wind turbine, but your wind turbine is not designed for a hurricane. So you have a very huge load. Fortunately, this guy is strong, so he is standing up, but here we have some problem here. He got failure because he was not able to take all the load, right? So we should make sure that forces are balanced. The other example is bridges were important. So these trust members already failed. What happened to them? They couldn't bear the forces and they said, okay, I'm going to give up. And they just failed. And the other one is a slope. So slopes, we always think that slopes are going to be stable because nothing is going to happen, but we don't know what will happen. You're going to have a hurricane or you're going to have a earthquake, which is going to shake your ground and induce a huge inertial force on the slope that can cause the slope to fail. So these are some of the things that can happen when you have an inequilibrium or when you have a failure. So do you have any questions so far? If so, you can put it in the chat window or you can ask, otherwise we can go forward. Okay, great. So let's go into the next section. So when it comes to forces, we cannot forget Newton because he has 3 laws which explain almost everything about forces that we learned before. First one is the object in motion is going to stay in motion. So you have a cup of coffee in my table. So I say my cup of coffee with the coffee is going to act because of gravity. And then the kitchen table, let's say, look, wait on, I will hold you up and it is balancing both. It will remain rest. So the object will be in rest, will stay in rest unless you give an external force. So I'm telling, okay, I want to drink my coffee. I'm going to pull the coffee. Fortunately, the force I'm going to provide is going to be greater than the kitchen table's force, so I can take the cup. So now the cup is in motion. So that's what Newton's first law says, that object in motion stays in motion or object in rest stays in rest unless an external force is acted upon. The Newton's second law of motion, then object with unbalanced forces, it experiences an acceleration in the same direction of force is applied. That's where we call it as F is equals to ma. If the force is acting and you are going to create an acceleration where your weight is going to be constant, right? So let's see what Newton's second law says. So let's take a sponge and a gold bar. And I'm thinking from, okay, well, let's go and put it on the top from somewhere I got a thought. Okay, oh, I'm going to throw it from the sponge and the gold bar from the top of the building. So what do you think will happen? Which will reach the ground first? Yeah, both of the objects are going to reach the ground first because why? The acceleration, that's the g, is going to be same. So your both objects will reach the ground same. But will the forces be same? Okay, let's imagine, unfortunately, when I'm putting the gold bar and the sponge, a person is standing here. 2 persons are standing. Let's see who is fortunate and not fortunate. One got the sponge, but one gets the gold bar. But both are going at the same time. But will the force that the person's going to experience will be same? No, right? Yes, because the acceleration is same, but the mass is different. So the gold bar is going to be heavy, which will make your force on this person will be heavy. He is gone. When the gold bar goes, he is gone. And the sponge, not bad because very lightweight, less force. So that's what our Newton's second law says. So the Newton's third law is simple. That is, every force of action has an equal and opposite reaction. For example, you have a gun, so you shoot the bullets. So the bullets are going, so accelerating in the direction. But is that all happening here? So after bullet goes, everything fine, the gun is going to be in rest? No, there will be a recoil force on the gun which pushes the gun back, right? So if you don't know that and you go and take the gun, and if you're not prepared for the recoil force, what happened? Done. You shoot and the gun comes back. Yes. So you should know every force has an equal and opposite reaction. Same with normally when you're standing, you give a force and then the external force act up. So that's Newton's third law of motion. So I hope that you have recalled the 3 laws of motion. If you have any questions, you can ask.